Today we're going to be solving an absolute value inequality. This is definitely one of the more challenging problems that you'll see in intermediate algebra. It's really only challenging because it contains a lot of steps, but each individual step is not a big problem in and of itself. We just have to remember how to proceed each time. The best way to do that is to just work a bunch of examples. So we're going to work an example here and really concentrate on the steps. So here's our example. 3 times the absolute value of 2x minus 3 minus 4 is greater than or equal to 2. Our first step is to just have the absolute value part isolated by itself on the left side of this inequality. So we need to get rid of this minus 4, we need to get rid of this 3, but that's easily done. We just use our normal techniques of solving equations or inequalities. So first we move this 4 over to the other side by adding 4 to both sides. That will eliminate this minus 4. Give us this situation, and we get rid of this 3 multiplier by dividing both sides by 3, and now we have our absolute value sign of 2x minus 3 isolated on the left side. 2 is on the right side, so we are ready to proceed. The next step is to split the absolute value inequality into a compound inequality. We can deal with those a little bit easier. So the first inequality is going to be just the same as what we had earlier. We just drop the absolute value signs, and that becomes our first part of our compound inequality. The conjunction in the middle is based on the inequality from our simplified form here when we've isolated our absolute value. If it is greater than or equal to, in this situation it will always be or. If it's less than or equal to, it will be and. But in this case, since we've got a greater than or equal to, our conjunction will be or. And our final part of the compound inequality, we drop the absolute value symbols, we switch the inequality. It was greater than or equal to, it becomes less than or equal to, and we change the sign of our number on the right, and it was 2, it becomes negative 2. Our next step is to simplify each inequality. So what we want to do is take these and get them down to x is less than or equal to, greater than or equal to some simplified number before we proceed. And that's easily done again. We just use our normal operations of solving equations and inequalities. We will add 3 to both sides. We will divide both sides by 2 in both cases, and that will get us down to our simplified compound inequality, which is x is greater than or equal to 5/2, or x is less than or equal to 1/2. At this point, it really helps to graph each inequality on the same number line, and when you do that, the interval notation for the solution will be a lot easier to come up with if you can see a picture of the solution. So what I'm going to do is I'm going to first graph x is greater than or equal to 5/2 in blue, and then I'm going to graph x is less than or equal to 1/2 in red, and then I have a picture of our number line with the intervals shaded. I can separate the two by the 2 colors, and I can really see what's going on. So here's my number line. I'm going to go ahead and do my shading. My first interval was x is greater than or equal to 5/2. 5/2 is 2.5, so since it's greater than or equal to, I'm going to need a bracket, a square bracket, because the number 5/2 is actually going to be in my interval, so I always denote the endpoint with a bracket when the endpoint is in the interval. So I want a bracket at 5/2, and I want the numbers greater than or equal to 5/2, so I would shade to the right, which is the positive numbers. That will give me the numbers greater than or equal to 5/2. The second inequality is x is less than or equal to 1/2, so that's going to be between 0 and 1. And so again, I need a bracket because I want 1/2 in my interval, and it's going to be opening to the left this time because we want the numbers less than or equal to 1/2. So I shade to the left, and that will give me a picture of my solution. We want all of these numbers from -infinity up until this point, which is 1/2. We don't want any of these numbers between 1/2 and 5/2. Then we do want 5/2 and further on to infinity. So now we have to come up with an interval notation for this picture. So at this point we have to remember that OR corresponds to union, so we're going to want the union of these two intervals. Again, AND corresponds to intersection, but in this case we have OR between our two inequalities, so we want the union of these two intervals. So this is going to be -infinity to 1/2 bracket union bracket 5/2 to infinity, and here is how we write our answer. So whenever you have the union of two non-overlapping intervals, your answer is going to look like this, except of course your endpoints will depend on the inequality, but you'll always have -infinity to something, union something to infinity. The other common answer that you'll get is an intersection of two overlapping when you have an AND in there. In that case, it'll just look like one interval from some number to some number, and the parentheses or brackets will depend on the inequality. But this is our answer for this one. Keep working examples and you should be fine.